Bet you can't guess what's in the box, except that I put the title on the thumbnail that says what it is. Pretend you can't read and try to guess anyway. Stand by. Hey everybody, welcome back to RATTLECAN Fab Shop. I am James, and we have a new tool for the shop, and let's get it unpacked. I ordered this on the afternoon of the 4th of July weekend, and it was here on Tuesday afternoon, a day earlier than the UPS said it was going to be here. Did you have an enjoyable 4th of July? I worked. Well, I worked in the yard. I mean, it's still work, but anyways. What do we have here? We have, first of all, the manual for what our new tool is. This is the PrimeWeld CUT 60. It's a 60 amp plasma cutter. Part of the long-term plan for acquiring stuff. Ooh, sexy, sexy glossy paper. This is all the standard stuff that you're supposed to know. Specifications, everything's in color. Everything is clearly labeled. More installation stuff. How-to, a basic how-to, how to troubleshoot stuff if things go wrong, which is usually operator error. More maintenance and troubleshooting. This is good stuff. This is what you're really looking for right here. The PSI setting reference table and the cutting speed reference table, and this is based on a combination of amps, PSI, material thickness, a torch to work distance, which looks to be for the most part set, optimum cut speed. If you're doing it handheld like we're doing, that's kind of difficult to gauge, but we will, we'll just figure it out by trial and error. This will come in really handy if, I don't know, you got a plasma table, a CNC plasma table, because in order to do CNC plasma cutting, you have to have a plasma cutter. So this is the order in which we're going in. We've also got CNC connector pinout references in case your company doesn't supply one, or if you have to build one. There is also, this is something I absolutely love, wiring diagrams. In case you have to troubleshoot something, and then an exploded parts diagram, which is particularly handy, more so than some other suppliers, because this company will actually sell you parts. I have bought more than a few tools from certain dubious quality suppliers, and in the manual it will say parts are for reference only, and you call the company and they're like, well, we're not going to sell you that, which is somewhat exasperating. There's box number 2. Here is, I'm going to assume, box number 1. One of the things that I enjoy about the PrimeWeld stuff is they come with corners, just to keep stuff from getting crushed in shipping, because, I mean, I love my UPS guy, but man, they're gorillas when it comes to stuff. And it's just something that helps it get to where you want it to go. Let's readjust here a skosh, nay, maybe a smidge. What do we have in here? We have ground clamp, standard kind of ground clamp with the DINS connector on it. This is in case you want to run 110 voltage, you can do that. I've seen some other plasma cutters and they have this backwards. It's bizarre because this is supposed to go into the wall, carry your electrical current, which then connects from here to the machine. And this should be the big skookum connector, because if you don't use 110 wall voltage, then you're plugging straight into like 220, 50 amp. And I've seen of them that they just carry it on like a household cord, and that just don't seem right. But that's just me, what do I know? Here is the plasma CNC connector. And then I heard somebody refer to this as the cosplay welder's mask. My personal opinion, it's here for liability purposes. If you do something stupid, then they can say, I gave you a mask, I gave you a shade. It's your fault, not mine. That's box number one. Box number two is, let's see, spare consumables and the consumable wrench. And the IPT60 torch with the DIN style connector on it as well. Here's the business end, actually already assembled. It has one of these finger flip guards so you don't accidentally plasma your butt. What else do we like about this setup is we plug this in and we're in business. I believe they call this a Euro style connection. If I get it wrong, I'll put the right thing below. Anyways, this is like one-stop shopping. You plug this in and the thing works. I have been watching some videos on other types of plasma cutters, and man, you got like 4 or 5 different lines. It's a mess trying to get it connected up. This is one connection. Connect your ground clamp. Life is good. This is the typical PrimeWeld packaging. This is the big stuff. How big the stuff? Well, that's like 2 inches on the outside. Reinforced corners. You have this much. You have 3 inches of crush from the top before you actually get to the case. They're just knocking it out of the park. By the way, Gene, super nice guy. When you call PrimeWeld, you'll probably get Gene, and super nice, called me right back. He said he had people in the shop, and could he return my call? Well, what am I going to say, no? And so he did. He called me back within like 5 minutes. Boom, it was on the way, and we're off to the races. And here is the business end. You know what? Hold on a second. Let's reposition something here. All right, now that we've got it kind of set up where we can look at it a little better, I'm going to use this photograph that I've taken. I've taken one of the front, I've taken one of the back, and that is so that we can get a better picture and we can kind of look at the controls and the features on the front and the back. But of course, before we do that, we have to be properly prepared. That's the good stuff. Anyways, let's get going on the front. And what I have called number one is the amp display. This display is going to read anywhere between 20 and 60. If you are plugged in at 110 volts, it's going to read between 20 and 30 amps because that's what you're going to get out of a 110 volt circuit. If you are plugged into 220, it's going to read in between 20 and 60 amps. Now, from reading the manual, it is going to display what your amp setting is set at until you pull the trigger and the pilot arc starts. When that happens, it's going to go somewhere between 20 and 30 amps, and then once you actually make continuity, which means once you have completed the circuit, because we're having to complete an electrical circuit, then it's going to display the actual amps that you are using dynamically, because apparently that's going to change. You know, I'm guessing it's like welding, where depending on how far away you are from the metal, how maybe your speed, maybe your angle is going to change that. We'll have to find out. And we'll just go ahead and note it here. If you're on a 110 volt circuit, your maximum material thickness is 1/3 of an inch, or 8 millimeters. And if you're in the machinist game, that's 333 thousandths of an inch. If you're on a 220 volt circuit, that is, the manual calls it 4/5 of an inch. We would call that 800 thou, or 20 millimeters maximum material. The next feature we're going to look at is the OC light, indicator light. OC, of course, stands for oh crap, although the manual translates that as overcurrent. You have a duty cycle, and duty cycle is how long you can continuously operate a piece of machinery in a 10-minute cycle. And that is expressed as a percentage. So if you're on a 110 volt circuit and you are cutting at 30 amps, which is the maximum for 110 volts, it has a 60% duty cycle, which means you can cut for 6 minutes and then it's going to have to rest for 4. And that all has to do with thermal overload protection. If you are at 23 amps on 110 volt circuit, it has a 100% duty cycle, which means you can just cut and cut and cut and cut. This light will come on if you have pushed it past that limit. Your cutting functions will cease, but the machine will stay on and the fans will continue to run because it's trying to blow air across. There's a couple of heat sinks in there that it is trying to cool down. It should reset. If for some reason it doesn't automatically reset.
Yeah, have you tried turning it off and on again?
Turn it off, turn it back on again. See if that resets it. If that doesn't reset it, then you know you got issues. If you're on a 220 volt circuit at 60 amps, you've got the same 60% duty cycle, so 6 out of a 10-minute period. And then at 46 amps or less, it's a 100% duty cycle. And that is just this little light, and it'll come on and it will make you go, oh crap. The next thing we're going to talk about is the amp control. It is a knob. Knobs turn from one side to the other. The left-hand side is going to be lower. The right-hand side is going to be higher. The inside ring is going to be 110 volts. The outside ring is going to be 220 volts. The next knob is your post flow, and that is how long after you release the trigger from making a cut that air is going to flow through the machine to cool off your consumables. That can be set anywhere from 0 to 60 seconds, and that's about all it says. It says you have to set it at a level that's appropriate. I don't know what's appropriate. Am I supposed to be able to touch the tip of my consumable after my post flow turns off? I don't know. We'll have to find that out. Well, I don't know. I might not touch it, but you kind of get the gist of it. We'll see. Next up is our function switch. It has 3 positions. It has set air, It has 2T and it has 4T. And for some reason, this causes great angst and consternation. Set air is where you want to place the switch when you want to set your air pressure. If you set your air pressure and there is no air flowing through the plasma cutting head, you are going to get an erroneous reading because that air is going to compress inside the line. What you want on the reading on the gauge above there is you want to read the PSI during constant flow. So what you'll do is you'll set this switch to set air, air will flow, then you can set your PSI setting on the gauge, and when you have it at the appropriate level, then you can turn it back to either 2T or 4T. 2T and 4T dictates how the switch on the gun operates. 2T or 2-touch means you pull the trigger once and it is on, and when you let it go, it is off. 4T is kind of like cruise control. When you pull the switch, it is initiated, the arc is initiated. When you let it go, it is on at the level that you have set it at, and it will stay on. Now you have to be careful when you're doing this, because if you're on cruise control and you drop it, it's going to stay on until you get that trigger again and touch it again. So you pull the trigger, it initiates it, you let the trigger go, you're now on cruise control. It will stay on until you pull the trigger again and release the trigger again. You have to cycle that switch twice on the 4T. You cycle the switch once on 2T, a pull and a release. 4T is a pull or release. It's on cruise control, pull and a release to turn off. You either get it or you don't. Next up is our workpiece connector. Most people will probably refer to this as a ground clamp. This is a standard DINS connector. You have to have your workpiece grounded, or whatever your workpiece is sitting on has to be grounded, because again, we have to complete an electrical circuit in order for this to work. It's just like welding. If you don't have your ground connected up, stuff's just not going to work. If you're having problems, if your cut is not going well, check and see where your ground connection is. Check and see how far away from your workpiece your ground connection is. That could be the issue. Next to that is our torch connection. I believe this is what they call a European connection. One of the selling points on this plasma cutter is it's a one and done connection. You line, there's a notch at the 12 o'clock position. There is also a tab on the actual torch lead. You slide them in, because it'll only go in one way, and you hand tighten it. Don't go gorilla mode on it and tighten it with a wrench. Hand tight is good enough. But that is your air connection, and that is also your electrical connections and also your switch connections. Everything is self-contained. There are no extra leads that you are responsible for connecting up. You push it in, you twist it, and it's done. Easy peasy. Next, where you have the air pressure regulator, you're going to pull it until it clicks. Then, with the set air switch activated and air flowing through, you're going to rotate plus or minus to the PSI that is appropriate for whatever it is that you are cutting. And then when you are done, you're going to push it back in, and that locks the knob. And then the gauge above that reads from 0 to 150 PSI. And here's where I take issue with this design. This gauge is set at 150 PSI. Most people will look at that and go, oh, I have to make sure that my PSI is lower than 150 to go in there, so maybe I'll set it at 140. Caveat number one, if you look on the back of the plasma cutter, you'll notice that there is a label above your air inlet or your gas inlet connection, and it says max 120 psi. Well, I'm not a smart guy. 150 is different than 120. So I now have contraindicating conditions. Furthermore, if you read through the manual, which a lot of people are not going to do, if you read through the manual in bold print, it will tell you, do not set your inlet air pressure to more than 90 psi. I have an issue with that. You have a gauge that's marked 150 psi that it will read to. You have an inlet limit on the back of the machine that says 120 psi, and then you have a manual that says 90 psi. I understand these are built to a price point. I also understand that if you can't read, or you choose not to read and you screw up your unit because you just make an assumption and plug it in, well, that's on you. So pay attention to that. Also, it is going to say in the manual that your ideal operating pressure is going to be between 55 and 75 psi. So if you read that, then it's understandable why they don't want you to go any higher than 90, but then why do they put 120 on the back, and then why do they do 150 gauge? Well, it's because it's a standard gauge, is going to be my guess. Speaking of air, the manual suggests for your compressor 5 cubic feet per minute at 80 psi with a 20-gallon tank. That may or may not be achievable with your pancake compressor. If you're cutting, goofy car. If you are cutting thin sheet metal, you're going to be using less PSI, which means that you're not going to consume as much air, which means your compressor is not going to cycle as much. If you are trying to hog through 4/5 of an inch of stainless with a pancake compressor, you're going to be working it awful hard. Your compressor may run up upon its duty cycle and knock itself out. Your compressor is just going to be, the thicker material that you have, your compressor is going to be working more and more. So just take that into consideration. Let's go around and look at the back. On the back, we have a CNC connection. If you look on page 29 of your manual, it will give you the pin assignment. That is something that you and your CNC table manufacturer are going to have a discussion about. How you wire that connection up in there. They provide the port on the machine. They even give you the connection for the machine. How you get the signals from your CNC machine into that pin, that's between you and the manufacturer. But page 29 gives you the pin numbers and locations on the adapter. It also tells you what the corresponding wire assignments are for the CNC. I believe they call it a connectivity card. There's also a power cable. It's dual voltage. It's also dual cycle. If you're an overseas person, you'll know that if you have purchased a 60 cycle unit, but your country's running on 50 cycles, things don't run so well. But this is a dual voltage, dual cycle unit, so it should operate fine in either condition. This has a 2-pole power switch. People complain because the switch is on the back of these units. Well, if you want to sell stuff in the EU, that's what you got to do, because your circuit, your power switch has to be closely located to where your power cable enters into it. If it is a big deal for you to not have to reach around to the back of your machine to turn it on, then I suggest you get with your electrician and you come up with some sort of a box that has a switch in a location that you can more easily reach. And then you can just flip the switches, or a relay even, on the front of that, and that'll activate whatever you need to do. They're doing that because they don't want to make a separate machine for the States. with a conveniently located switch on the front, and then another machine that is available into the EU. That's pure conjecture on my part, but economics says that's probably what it is. It's a 2-pole power switch, and what that means is you're basically operating 210 volt legs, because that's how you get 220 power, is by putting two 110 legs together. There is a warning in the manual about using home 4-wire to 3-wire adapter connections, because some people, when they are wiring up dryer circuits, do not follow convention, and they will sometimes swap out a hot leg and a common leg, and that is the no bueno. If you are on the PrimeWeld Facebook page, and if you're considering a PrimeWeld product, or if you have purchased a PrimeWeld product, I strongly advise that you join that Facebook group, because someone was just having an issue with one of their welders only going up to a certain amperage, and it was quickly discovered that their freshly added welder circuit was wired up incorrectly, and they were only getting power to one leg instead of both legs. That's why they only had half the power. So pay attention to that. If you know how to do it, fine, do it yourself. If you don't know how to do it, find a buddy, find an electrician. It's money well spent rather than blowing up your machine. There's also an air inlet connection. It is what's called a G-quarter connection. This is not a national pipe taper connection. It does not get tighter and tighter as you tighten it up. It is a parallel thread. The threads don't taper down to make a tight connection. From what I was able to find on the interwebs, this is pretty popular with the water cooling systems on computers, for your big overclocking gamer kind of guys, building these big skookum water-cooled computers. It's a connection that they use. There was some reference to gaskets on there. My understanding is that these are going to function fine, but just to be on the safe side, and since I know it's not a tapered thread, I am going to use some Teflon tape to do this. It's brass, so again, don't go gorilla on it. You tighten up, hand tighten it, and then maybe with a wrench go 1/8 of a turn, a quarter turn. And since you're using gas, it's always good to just do a bubble check. A little bit of soapy water, hit the set air switch to get a flow of air in there, and make sure that your connection is tight. That's the front and the back panels. There are no access panels. There should be no reason for you to go inside of this machine. In fact, if you read your manual, it'll tell you that it voids your warranty if you open the case. So keep that in mind. If you are in a dusty environment, there are fan outlets. There are little louvers on the front and the sides and the back. If you're in a dusty area or an area that there's just a lot of crap floating around, like, I don't know, a metal shop, you might want to think about blowing that out every once in a while. So anyways, that's the front and the back of the units. That concludes part 1, where we unboxed the unit. Part 2, where we reviewed the controls on the front and the back of the units, and we talked a little bit about some things to consider. Part 3, which is going to be in the next video, getting it set up to run, setting up a filter, some ideas about getting filters set up, some considerations for supplying air to your system, and then we may do a couple of cuts on a couple of different pieces of material. Anyways, that's the new tool that we've got in the shop. It's the PrimeWeld CUT 60 amp plasma cutter. You are in the $700-ish range for 60 amps and CNC table connectivity with a standard consumable style torch, a blowback style torch. not a high frequency, which could be an important consideration if you're running a CNC table and high frequency. Anyways, I'm James. Be sure to give us a thumbs up if you think this was informational or entertaining or some mix of both. If you've got somebody that is considering purchasing a plasma cutter, if you think it's worth it, why don't you share this with them? Be sure to put any comments you have down in the comment section beneath the sermon notes. And be sure to subscribe so you'll know when the next episode comes out, where we hook this thing up and we start doing some cutting. Anyways, you guys have a good one. Cheers. Thanks for taking the time out of your day to spend it here with me. Hope you enjoyed this video. Here's one that you might enjoy as well. If you're not already subscribed, be sure to hit that button, hit the bell next to it so that you get a notification when we drop a new video. If you've got comments, put them down beneath the sermon notes. And remember, if I can do it, you can do it. You guys have a great weekend. Cheers.